Hello and welcome to Cannon County High School Algebra 2. Today is day 2 of doing probabilities using permutations and combinations. Yesterday we did CC.5 all the way up to 50%. Today we're going to see if we can get that all the way up to 80%. We're splitting this up into 2 days just to make these videos a little bit shorter and easier to deal with. So Mr. Lyon, I'm going to have you sit over here and see how we do. And let's talk about this first. Just a little quick review. Remember, we're using this formula, the probability of an event. This is all the work we did yesterday. The probability of an event is the total number of outcomes of the event divided by the total number of outcomes possible for that event. And sometimes order matters, in which case we're going to be using permutations, and sometimes order does not matter, in which case we're going to be using combinations. So if you haven't seen yesterday's video yet, go back and watch that one first, because it will make today's a little bit easier. So you can see we're at 50%. Let's see if we can go up from there. Mark's city is always full of tourists. So many cars display out-of-state license plates. On his walk to work, he passed 10 cars, 4 of which had Nevada plates. If Mark checks the plates on 7 randomly selected cars, what is the probability that exactly 3 of the chosen cars had Nevada plates? Well, just like yesterday, the first thing that we want to figure out is, does order matter? Are they talking about what order these license plates are in? No, they're not, and therefore we're going to be using combinations. All right, so first we need to figure out the denominator, which is the entire sample space for the entire problem. So ask yourself, how many cars does Mark have to choose from total? 10. How many is he selecting at random? 7. So that means in the denominator we've got 10 choose 7. All right. So I'm going to do the work here again. In the denominator we've got 10 choose 7. Okay. Now let's figure out in the numerator what he's trying to do. Let's see. On his walk to work, he passes 10 cars, 4 of which have Nevada plates. If he checks 7 randomly selected cars, what's the probability that exactly 3 have Nevada plates? So we're going to figure out 2 things for the numerator. One is we're going to figure out all the different ways that there can be exactly 3 Nevada plates. And then we have to figure out all the different ways that the rest of the plates can happen. So first let's do the Nevada plates. He's selecting 3 from how many? There's 4 possible. There are 4 cars that have Nevada plates. He's going to select exactly 3. So that means he has 4 choose 3 Nevada plates. So on our work here, we're going to put 4 choose 3. Now look at what we've selected. We've selected 3, but how many are we selecting total? 7. That means we have to choose another 4, right? These 2 numbers really have to add up to that number. We're choosing 3, we're choosing 4, we're choosing 7 total. Well, how many non-Nevada plates are there? Let's go back and see if we can reread the problem. If there are, let's see, 4 cars that have Nevada plates and there are 10 cars, that means that there are 6 cars that do not have Nevada plates. So when we go back here, when we're figuring out we're choosing 4 non-Nevada plates, there are 6 to choose from. So take your time setting up these problems. Have it written out kind of like this. We're choosing exactly 3 that have Nevada plates. We're choosing exactly 4 that don't have Nevada plates. And we're choosing 7 out of a total 10. So now it's time to bust out the calculator finally. And let's figure out what these are. So if you don't know how I'm calculating these, you're going to have to go back a video or 2 to figure out how we do combinations and permutations using the calculator. But 4 choose 3 is 4. Now let's try 6 choose 4. Six choose 4 is 15. And now 10 choose 7. 10 choose 7 is 120. So 4 times 15, that's 60. 60 divided by 120, well, I don't even need a calculator for that. That's 0.5. So that means that the answer is going to be 0.5. So take your time setting these up. It will pay off in the end. All right, let's try another one. We're up to 60. We're trying to get to 80. Elizabeth got a summer job at a movie theater cleaning aisles after each film. This Sunday, 9 movies are scheduled to show, 3 of which feature an animal as the one main protagonist. If Elizabeth is randomly assigned to clean up after 4 movies in a certain order, what is the probability that just the first 2 of the chosen movies feature an animal as the one main protagonist? Well, you can see there's something different about this problem already. It's talking about in a certain order. And it says the first 2 of the chosen movies. So in this problem, does order matter? It would appear so. Yes, it does matter. And so instead of using combinations, on this one, I think we're going to have to use permutations. Okay? So the idea is still the same. It's just we're going to be using permutations instead of combinations. So let's figure out the denominator first. Let's see, this Sunday there are 9 movies scheduled to show. How many movies is she assigned to clean? Elizabeth is randomly assigned to clean 4 movies. So we've got 9 movies, and she's going to be cleaning up after 4 of them. So that's 9 choose 4. That goes in the denominator. That is the sample space. We have 9 choose 4, but we're going to be using permutations instead of combinations. Now let's figure out the numerator. We've got 2 kinds of movies here. We have 3 where you have an animal as the lead character. So let's figure this out here. We've got 3 that have an animal as the main character, and she wants to find out what is the probability that just the first 2, okay, so again, order matters, excuse me, but the first 2 feature an animal as the main character. So you've got 3 to choose from, and you're choosing 2. I think you're starting to figure this out. Yeah, you got 3 choose 2. 3 choose 2. All right, but now we have to figure out how many more things do we have to choose? If these first two have an animal as the main character, how many movies do we have total? We have 4 movies. So that means we have another 2 to choose from, or not to choose from, but to choose rather, that don't have animals as the main character. So we need to figure out how many movies are there that don't have an animal as the main character. Let's go back to the problem here. It says there are 9 movies, and 3 of those movies have an animal as the main character. So that means that there are 6 that don't have an animal as the main character. So I think we got it. I think we've just figured out that we've got 6 that don't have an animal as the main character. So here we go. Same kind of problem as before, but this time order does matter. So instead of doing combinations, we're doing permutations. So here we go. Let's figure this out. We're going to use a permutation of 3 choose 2. And that comes out to 6. Now we're going to do 6 choose 2. Can't talk today. 6 choose 2 is 30. And 9 choose 4. Nine choose 4 is 3,024. Okay, so 6 times 130, that sounds like 180. So we need to do 180 divided by 3,024 to figure this out. 180 divided by 3,024. And that comes out to 0.05952, so we're going to round that down to 0.0595. 0.0595. type that in and see if we got it. You can see these are a little more complicated. 0.05. Oops, it would help if I had that highlighted. And we got it. Okay, but you can see there's a little more work on these than there were yesterday. Let's try this one. We'll do one or two more, and then we'll be done. Well, let's see. Let's jump up a level and see if they can make these any more difficult. We said we were going to get to, okay, let's go to this one. 76. If we can do 76, well, then we can do any of them. Let's see. Steve has 38 buttons, 31 of which are green. If Steve randomly selects 4 buttons, what is the probability that exactly 2 of the chosen buttons are green? Okay. Well, what do you think about permutations or combinations? Does it make any difference what order these are in? I don't think so. I think this is going to be another problem where we're going to use combinations. So Steve randomly picks 4 buttons. How many buttons does he have to choose from? He has 38 buttons to choose from, 31 of which are green. So he's going to choose 4 of them. So it looks like 38 choose 4. 38 choose 4. Oops, I put that on the top. Here we go. 38 choose 4 is going to go in the denominator. Okay. Let's figure out the numerator. He wants 2 of them to be green. Doesn't say they have to be in a certain order, it just says they have to be green. So how many green buttons does he have to choose from? Well, he's got 31 and he's choosing 2 of them. So the first part of the numerator is going to be 31 choose 2. 31 choose 2. But now, just like on the previous problems, we chose 4, we've already chose 2, so how many more do we have to choose? We've got another 2 to go, don't we? But how many non-green buttons are there? Aha. Steve has 38 buttons, 31 of which are green. So that means there's 7 buttons that are not green. And if he's choosing 4 buttons, 2 of them are green, that means the other 2 have to not be green. So therefore, we've got 7 buttons to choose from. We're choosing 2 more non-green buttons. So it looks like we have 7 choose 2. So you can see on these kind of problems, this number and this number has to kind of add up to that number because that's what we're choosing. All right, let's see how we did. 31 choose 2. (31 choose 2 is 465. 7 choose 2 is, I don't know if you saw that or not, 21. 38 choose 4. 38 choose 4 is 73,815. So let's see, we're going to take 465 times 21, and we're going to divide all that by 73,815, and we get 0.13229. The 9 says we're going to round that 2 up to a 3. So 0.1323. 0.1323. And let's see how we did. 0.1323. And we got it. Okay, we're up to 80. So what I'd like you to do is see if you now can finish this off. Maybe you figured this out yesterday, I don't know. But see if you can get your CC 0.5 on IXL all the way up to 80 using permutations and combinations. We ended up only doing one problem in the 2 lessons that used permutations, but I have a feeling when you do these, you're probably going to get more than one. Just remember, the way to figure that out is if in the problem they talk about a specific order or something having to be first or something having to be last. That's kind of the key to when you're going to use permutations. Order matters with permutations. Okay? So thanks for watching, and we will talk to you tomorrow. Bye.